Hey, I'm Ches and welcome back to the Outlaw channel. So in today's video, I wanted to discuss another technology slash company that I really believe is going to be incredibly disruptive for the architectural and design industry. And yes, yet another one of Elon Musk's companies, which I've already mentioned in one of my previous videos, that is Neuralink. So I'll briefly explain what Neuralink is and what its applications are for those of you who don't know. And then I will share my opinion about the different ways in which I believe this powerful company is going to change the world as we know it in ways in which we yet cannot comprehend. So without further ado, let's get to it. So what is Neuralink? So Neuralink basically is the brain connected to a computer, made simple. Eventually someday that will help humans compete with artificial intelligence. So this is actually one of the main goals. So it's a brain implant, or call it a computer chip, roughly the size of a large coin, into the human brain via a robot surgeon. So the chip, which Neuralink is calling the link, will wirelessly connect the brain to the digital world. And how do we do that? Just starting by connecting to a smartphone. Far-fetched, you know? If you think about it, it's not that crazy of an idea. Really, it was decades ago that we started playing with brain-computer interfaces. 2 decades ago, we had a much more rudimentary accessory for this, like this one in the video. Purpose? Detecting a brain signal that analyzes and translates said signal into a message that can be carried out by a device external to the brain is the main purpose of this. If this is the first time that you're hearing about Neuralink, stay tuned, because shortly I'll show a video of Neuralink and the actual brain implant in action, and I'm telling you, you're going to be blown away, like guaranteed. So I think this video is really about understanding how Neuralink affects, or could affect in the future, our industry of architecture and design. And so really, why is it fundamental to our industry? And so our industry's intrinsic value, in my opinion, could be just, let's say, to be very, very simplistic about it, but to keep this elementarily understandable, is that our industry can be divided into 2 core elements and 2 core components, and those be designing and drawing, where drawing perhaps is related more to the production side of things. Let's keep the design component out for now. And so if we look back into the history of architectural drawings can date back to Egyptian and Mesopotamian times. We can then pinpoint Western architecture to be generated first in classical Greece, and then Roman plans. Then, before the Renaissance, architectural drawings as we intend them were very rare. It became more and more common to draw during the Gothic period in the 13th century. And concept works, sketchbooks or patterns books came afterwards. And then, of course, architectural drawings almost as we know them today. Now let's think of how innovation improved the way we do things in architecture, replacing hours and hours of drawing by hand, like for example manually drawing topography, contours, calculating levels, drawing accurate plans and sections or elevations. Basically the dedication of hours and hours and hours of work, and especially very, very healthy positions. One of my bosses still reminds me today, what today is as instant as a simple click was before done by hand, with hours and hours and hours. And in here, I'm not saying that drawing by hand it's a bad thing or it's right or wrong, but you have to be objective. You have to be honest and admit that certain tasks we no longer do them by hand because they're much more reliable and effective if done digitally. And there is a huge amount of time saved thanks to that. Technology has improved the situation. We can all agree on this, right? So computers helped. Softwares that facilitated certain tasks were made. And so now finally time can be saved. Or at least they can be dedicated on other tasks such as designing, refining details, creating a more sellable concept, improving the design. The more mechanical tasks can be minimized. And so then the virtual and augmented reality came as well. And so augmented reality, which is a live view of real world environment whose elements are augmented by computer generated inputs. So augmented reality takes the real world and add the 3D model of a design. And this comes with huge advantages. You know, models can be viewed on a smartphone, and thanks to real world coordinates, the design can be recognized even on site, for example, and overlaid in a particular context. For augmented reality, we could use the example of Pokemon Go, a game that could be played on a phone. And this was basically a super breakthrough augmented reality app for gaming that, like I said, uses your smartphone camera and the GPS to create locations, to create a locations-based augmented reality environment. I had colleagues a couple of years ago in my previous practice that they were almost obsessed with it, and they would go play this game during their lunch break. And to be fair, there's something quite funny about it, the fact that it creates almost a community of people, and some of them were actually meeting each other outside, and they were actually prompted to go and visit certain places that they otherwise wouldn't have visited, just because the app would allow you to go and find a particular Pokemon in that particular location. So they'd go out, they'd go to places, and they would sit down or stand and, you know, catch different Pokemons. Some argue that augmented reality could lead to another industrial revolution and then eventually lead to digital addiction. But with the implementation of a brain interface, this revolution is taken to another level. Now, with Neuralink, you can do an action, record the brain activity that that action generates, and then translate it. So the activity that the brain generated because of an action that you do is then translated into a code, which is stored, saved, and is repeatable. I'm going to show you the Neuralink demo that was live a few months ago before I give my opinion on how Neuralink could affect the architecture and design industry. As you watch the video, just let me know in the comments what you think about what you see.
This is Pager. He's a 9-year-old macaque who had a Neuralink placed in each side of his brain about 6 weeks ago. He's learnt to interact with a computer for a tasty banana smoothie delivered through a straw. We can interact with the Neuralinks simply by pairing them to an iPhone, just as you might pair your phone to a Bluetooth speaker. The links record from more than 2,000 electrodes implanted in the regions of Pager's motor cortex that coordinate hand and arm movements. Neurons in this region modulate their activity with intended hand movement. For example, some might become more active when he moves his hand up, and others when he moves it to the right. By recording from many neurons and feeding their activity into a decoder algorithm, we are able to predict Pager's intended hand movements in real time. First, we calibrate the decoder by recording neural activity as Pager uses the joystick to move a cursor to targets presented on the screen. As he's playing this game, we are wirelessly streaming, in real time, the firing rates from thousands of neurons to a computer. Using these data, we calibrate the decoder by mathematically modeling the relationship between patterns of neural activity and the different joystick movements they produce. After only a few minutes of calibration, we can use the output from the decoder to move the cursor instead of the joystick. Pager still moves the joystick out of habit, but as you can see, it's unplugged. He's controlling the cursor entirely with decoded neural activity. Our goal is to enable a person with paralysis to use a computer or phone with their brain activity alone. Because they wouldn't be able to move a joystick, they would calibrate the decoder by imagining hand movements to targets. One of the things the Neuralinks allow Pager to do is to play his favorite video game, Pong. To control his paddle on the right side of the screen, Pager simply thinks about moving his hand up or down. We've removed the joystick altogether. As you can see, Pager is amazingly good at mind Pong. He's focused, and he's playing entirely of his own volition. It's not magic. The reason Neuralink works is because it's recording and decoding electrical signals from the brain. Great game, Pager. And what better reward for a monkey than a banana? We still have challenges spanning many fields of engineering.
That That's crazy. First reactions? A monkey with a brain implant can play a game with her mind telepathically. Can you imagine the clicking that you can avoid? All of the typing commands like trim, extend, copy, duplicate. Okay, funny, but let's try and understand how this technology could improve or disrupt our industry. Let's just try and make a list. So I was thinking the first one could be, if you imagine yourself as an architect working on a project and you working collectively with other consultants, you're receiving drawings, say a DWG. Now let's assume that we need to merge the drawings that we receive with our own. So we need to clean these drawings that we received. So that may mean purging, trimming, auditing. What a Neuralink implant in our brain could allow us to do is to basically do those actions one time, say trimming 2 lines or purging all layers, all of the commands that you could possibly think about that you do on a daily basis. Neuralink allows us to record those commands, and so next time or every other time that we need to do them, we no longer need to be doing clicking and typing. The implant just allows us to think about those commands and the computer will do it for us because of the wireless connection. And think of it, we could probably do that on any software and for any action or command that we may need to use. Short-term Neuralink is to be used for medical purposes. So for example, allowing people that have paralysis to move certain parts of their bodies that they're not able to move. It can make headaches go away. It can identify strokes or heart attacks or other critical conditions that need instant prevention. And then it will alert us that some of these things are about to happen. But long term, what could that really mean? As architects and designers, we would still need to use mouse and keyboards. That's a start. That's a lot of accessory money saved. Another crazy idea could be, so let's call it point 2, that if you're somebody who draws a lot, say you're drawing by hand or you're drawing on paper or on a tablet or iPad, you could think of any stroke with your hand. The stroke has a response to your brain. That brain generates that activity and the activity can be recorded. If you record any of those strokes, you could just think of them the next time. Think of how much time is saved. Or what about working on 3D models? All of those repetitive commands like surface, scaling, extrusion, boolean, merge, hide and mirroring, hiding, and many more. All of those commands can now be recorded and then boom, now you just have to think of what model you want to build and you could do that. Like Pager the monkey playing Pong. One more aspect that I was thinking about is that of languages, learning new languages. Let's speculate that through Neuralink we could upload several languages onto your system, your brain. And so you could completely disrupt those architects that are hired because they know one language and they're useful for a particular project in a particular country. Say, for example, in my office there is a Chinese-speaking person, and for a project in China, she'd be the one to take care of client coordination, having certain direct presentations, translating any feedback that we get back. What happens when this person is gone? Maybe she's on leave, or what if she's leaving for good? In that case, a company, what traditionally would do is to find another person who's speaking that language, in this case Mandarin, and problem solved. Well, no, because with Neuralink, you no longer even have to have this person. So anyone that has a brain implant can just pick up that language. And I'm not saying that this is my preference. At least I want to expose people to this technology, but I wanted to share the possibilities and my opinion about this technology out loud, to make people aware that these technologies even exist and they are coming. At least we should begin to understand what the possibility of the disruption is, and then eventually even learn to embrace the technology and then spread this knowledge amongst ourselves, colleagues, family and friends. In an industry that is ever so competitive and every practice basically always lowering its costs, lowering the fees to be even more competitive, lowering the salary of staff and putting more emphasis on people working overtime to achieve nuts deadlines and unthinkable time targets. I think it's here the Neuralink in the nearest future could potentially help. So what do you think of Neuralink? Do you think that it'll have an impact on the architecture and design industry in any way, shape or form? You know, that markup that you wanted to do maybe today takes you 1 hour or 2 hours, and with Neuralink it might take you 10 minutes. Or you think that this is yet another one of Elon Musk's crazy ideas to bring humanity closer to a Terminator-like scenario where artificial intelligence goes rogue and the humanity goes to shit. Let me know what you think in the comments, and as always, thanks so much for watching. And if you enjoyed the video, hit the like button, don't forget to subscribe to my channel, leave your comments below and let me know your thoughts. And if you have any ideas for future videos, let me know. Until next time, bye!